So here's a video reviewing unit conversions and a lot of the concepts that we talked about earlier in the school year. So first of all, reminding you what unit conversions are. They allow you to use conversion factors to convert between one set of units and another set of units. We also refer to this as dimensional analysis or factor label method. So first of all, let's talk about conversion factors. So those are things that are truly definitions of how many items there are in one unit are equivalent to something in another unit. So for example, 12 inches equals 1 foot. Those are equivalent. It is a definition, and that is one conversion factor that many of you know already at this time. Another one is 1 hour is equal to 60 minutes. That's another conversion factor. So when we take these conversion factors and you write them as a fraction, since they're equivalent, they're the same as writing 1 over 1 or 2 over 2, which is the same thing. So anytime we multiply something by the fraction 1 over 1, we've really not changed that original item. So if we take something like 5 and multiply it by 1 over 1, it's still 5. Or if we take 5 and multiply it by 2 over 2, it's still 5. So we really haven't changed what our original data is. We've just attempted to use a conversion factor, which is basically 1 over 1, and change the units. So there are lots of conversion factors, and there are way more than we can possibly memorize. Some of them we already know because we know a lot of the conversion factors for time, but it's not important that we do memorize them. What's important is that we know how to find them. So we have many different conversion factor charts. You have one in your school planner. There are lots of them available on the internet, and there are many of them, and they all have their pros and cons. So my favorite one is one that I used in school, and it contained pretty much everything that I needed for unit conversions in both undergraduate and graduate school. Now, there are certainly easier ones that tell you when you want to convert from one unit to another, just multiply by this number and you get the right answer. Or maybe divide by this number and you get the right answer. And I really don't like those. And the reasons that I don't is because there could be a mistake in the number given and it would be hard to know. Or it could tell you to multiply and you were really supposed to divide and you really wouldn't know. But it also assumes that we're not smart enough or capable enough of being able to do this on our own, except by punching a number in a calculator, which is, I think, a little insulting. So part of this class is set up for you to learn how to think about things that maybe you haven't had to think about before. And so I think this is important for you to do. This is a very common thing that's done in chemistry. You'll find all chemistry students do work on this throughout the year, and I still think it's important, which is why we spent a lot of time and you guys did a lot of practice with it earlier in the semester. So this is the conversion factor table that I use, and again, I like it because there's so much in it and I really don't need a whole lot of other things. There are a couple of things that I needed to add and write on my copy, but for the most part, this contained everything that I needed to know, and it's small. It fits on a little over half of a sheet of paper, and I don't, again, need anything else. So how do we use it? So if I look at the section that has length in it, it's got two different equivalent statements here. It's got this 1 meter is equal to 100 centimeters and this many millimeters and microns and angstroms. And it's also equal to this many inches, feet, yards, and miles. Then it's got a whole second set here where it says that 1 foot is equal to 12 inches and a third of a yard, this many meters and this many centimeters. So it's got two different sets of conversion factors under the section called length. So all of these items that are circled in this one color are equal to each other, and I can pick and choose between them depending on what units I have to convert between. So if I want to convert between meters and inches, I can see that 1 meter is equal to 39.37 inches, and that's in this first group. I can also see in this other line that 12 inches is equal to 0.3048 meters. So you could use either of these conversion factors when you need to convert between meters and inches, or vice versa, and both of them are correct. So conversion factors setting up as fractions. So that conversion factor of 1 meter equals 39.37 inches. When we write it as a fraction, we can do it in two different ways. We can either write it as 1 meter over 39.37 inches, or we can write it as 39.37 inches over 1 meter. Either way, this fraction is still equivalent to 1, and we're multiplying by either one of these. We have not changed the original information. We're just trying to change the units. So how do we know which one we want to use? Well, it's going to depend on what we need to write in order to cancel units. Because remember, as we showed some examples in class, we talked about whether we have stuff on the top or the bottom, and we're going to see that in the steps ahead. So we have this kind of guided notes that we used in class where we filled in these steps, and hopefully you still have access to this. So number 1, we identified our known and our unknown, or what we're trying to find. Number 2, we wrote out a plan of conversion factors. 3, we set up a table with the known units in the upper left. Number 4, we added our conversion factors to the table with the known units going in the bottom because we're considering conversion factors like a fraction. We cancel units and perform math, recognizing that anything that's across the top will get multiplied and then it will be divided by any numbers that are in the bottom. So the first example that we worked through in class was what is 54.7 in inches in feet? So our known is 54.7 inches. Our unknown was how many feet. We know that we need to convert from inches to feet and that there are 12 inches in 1 foot. So we set up the table. We've got 54.7 inches up here in the very top. And then I have to figure out how am I going to write this conversion factor as a fraction in order to have it set up in our table so that our inches that are up here in the top will cancel with some inches in the bottom. So this is just like working with fractions that you guys have done in math class. So we want the inches up here in the top to cancel with the inches here in the bottom. So that means we're going to write 12 inches here and we're going to write 1 foot there. So once we've done that, we can cancel our units. We've got inches canceling with inches. We're left with 54.7 feet on the top, and we divide that by 12. Then we can do the math and write out the answer. So for this one, we have to still pay attention to sig figs. And since there are 3 sig figs in our original number here, we've got to write our final answer with the correct number of sig figs. And I believe that's 4.56 feet. So that would be our answer for this problem. So another example that we did back when we were filling out this guided note sheet was how many seconds are there in 5 days? So our known was 5 days. Our unknown is the number of seconds. We know we're going to have to convert from days to hours to minutes to seconds and use a number of different conversion factors to get there because I don't happen to know this number off the top of my head. You might. So 1 day equals 24 hours, 1 hour equals 60 minutes, and 1 minute equals 60 seconds. So we start out by writing our table. 5 days is our known and goes up here. And then we start writing our conversion factors in so that we can cancel units. So we've got days up here in the top. We know that we've got to have days in the bottom. So we're going to take the first conversion factor, which is 1 day equals 24 hours. So 1 day goes here, 24 hours goes in the top. When we cancel those units, we have days and days. We're left with hours. So we know we need to take a conversion factor using hours and put the hours down here in the bottom. So we've got 1 hour equals 60 minutes. So we need 60 minutes in the top and 1 hour in the bottom. Then we're left with canceling our hours, and we got minutes up here in the top. So we're going to do the same thing. We've got 1 minute in the bottom, and we need to have 60 seconds in the numerator. And then we can cancel all of our units, And we're left with 5 times 24 times 60 times 60. It's going to be divided by 1. And our units are going to end up being seconds. So when we multiply all of that out, I get 432,000. This is 5 days, and I'm going to think that this 5 days is exactly 5 days. So we really want to know exactly how many seconds this is, so we're not going to round with this one. This is really not a measurement. This is a counting number of days. So this is 432,000 seconds exactly. So our third example when we did this in class was having feet per minute, and we wanted to convert it over to feet per second. And then later on, we were going to convert it over into meters per second. So 5 feet per minute, we know that we have to convert the minutes over into seconds, and we know there's 60 seconds in a minute. So when you write your first known here, 5 feet per minute, you're going to want to write it so the feet are in the numerator and the minute are in the denominator. I've seen many people, especially on the last test, write the feet per minute all crammed up here in this little corner, and then you end up multiplying when you should divide and dividing when you multiply, and you get the completely wrong answer because you really never converted your units. So what you want to do is have feet in the numerator, minute in the denominator. We're going to go ahead and recognize that minutes are down here in the bottom. So when we go and convert, it's going to be 1 minute over 60 seconds. So when we do that, we are going to end up with 5 divided by 60. And the answer that I get is 0.08333 feet per second. Now, this is a measured item, so this is measured versus counted. So this would have sig figs, so it has 1. So I end up with 0.08 feet per second. So we can convert it over to meters per second. We did that in class. I'm not going to work through it, and I don't have it on this worksheet, but I want to work through a couple of other things. So a couple of other examples that we didn't do in class. So how many seconds are left in school before Thanksgiving break? Obviously, this is from a different time of year. Assume that it's 34 days until break, and we 7 hours we're in school each day. So if we set it up very similarly, our known is that there's 34 days. And we're trying to convert to seconds. We know that instead of 24 hours in a day, there's only 7 hours in the school day, because that's what we're caring about. But in those hours, there are 60 minutes, and in a minute, there are 60 seconds. So we're going to convert all of that using the same procedure. So 34 days starts up here. And we know that there are 7 hours in each day. We write it like this: the days cancel. We know there's 60 minutes in an hour, and the hours will cancel. We know that there's 60 seconds in a minute, and those will cancel. So we get 856,800 seconds. This is the exact number of seconds that you would spend in school. If we did want to round it to 2 significant digits, we would round it to up. It says to 87,000. That's not right. It would be 86,000. Okay, so I fixed that. So it says 86,000 now. So another example. Mount Everest is approximately 8,000 meters high. How many miles high is Mount Everest? So if I go back and I use the conversion factor chart that I showed back at the beginning, this is actually a one-step problem. So 8,000 miles, and our conversion factor chart says that there's 0.006214 miles in a meter. When we multiply those out, we get 4.9712 miles, because we can cancel the meters. And looking at sig figs, we can say that it would actually be 5 miles, because we would round that. So if we use the example, or another example of a car traveling at 62.5 miles per hour, how do we convert this to kilometers per minute? So when we take this, we have 62.5 miles per hour. And using the same conversion factor that we just finished using, we've got 0.0006214 miles per meter. And we can cancel our miles. And we also can do that there are 1,000 meters in a kilometer. And I need to still get rid of my hours and convert it over into minutes. So sorry, I have to continue this over onto the next line. I've got 1 hour and 60 minutes. So my hours cancel, so I'm left with kilometers and minutes. So I've got kilometers per minute. And when I do this math, I get 1.6763. If I look at this having 3 sig figs, I want to round this to 1.68 kilometers per minute. Okay. So a couple of things to remind you of. After you've converted, you have to pay attention to sig figs. So however many sig figs was in your original information, you need that same number of sig figs once you've converted to the new units. And this is because the conversion factors or equations have the unlimited number of sig figs because they're definitions. So you really only care about the sig figs in your original number, but you do want to pay attention to the fact whether you have to count it or if it's something that's measured. So I added a note here. Remember, things that are counted have an infinite number of sig figs, like 5 apples, 12 eggs, 10 students. But things that are measured are not infinite number of sig figs, and so they do have, you have to pay attention to those things in the number of sig figs. So in your final answer, that's what you have to pay attention to. So to kind of wrap up, I've got some practice suggestions. Really, this only gets easier with practice. You can look at all the answers and all the solutions from all the problems we did in class. They're all posted online. Everything you did on homework, I've posted my answer keys, but it really doesn't get any easier until you do them yourself. And I suggest you take a look at your Chapter 2, Part 2 test and see what you maybe did mistakenly there. There you may find that there was a consistent mistake that you made, especially in your unit conversion problems. I really don't feel comfortable posting additional practice worksheets because I think you guys have had a lot of practice, and I really think the best thing to do is to go back and redo some of your old problems because we do have all the answer keys. But this is one of those things that really only gets better after you practice it. So I think I'm going to end up making a separate video to talk about how to figure out how to convert between SI units. And because that was definitely something that a number of students struggled on, and I worked independently with quite a few students, and things definitely got better. So I'm going to set that up as a second video. So be watching for that. Hope you guys found this helpful. Thanks. Bye-bye.